I would do, because you can factor out a T out of the first two, and there's not much you can factor out of the second two, so you negative. Huh?
Negative one.
Yeah, negative one, be, yeah, you can factor out negative one. Trying to see if you could rearrange these, you know, give me another, the 20, maybe. Yeah, you can factor out that, you can factor out, switch to 20 and 3S. You could factor that around, and that would give you a little bit more numbers, and maybe do away with minus at the bottom of it. Let's do this. So, we could factor out, I don't know, that 3 and that S, sure, I don't know, let's try that. 15 ST minus 3S plus 20T minus 4. 20T minus 4. Group the first two and the last two. What's in common here? 3S. And that'll leave what? 5T minus what? 1? And then what's in common here? And then what does that leave you? Now what's happy about this? Why are we happy? No. Why are we happy? Well, what do you see that's in common? 5T minus 1. Is that what you want? You want something in common? Yes. So, what's in common? 5T minus 1. So you bring that down as something in common. And then what's left over? See, that one was able, you were able to do it, but you had to manipulate it a little bit. Yes, ma'am?
Why wouldn't you say that 5t plus or minus 1 is squared?
Because what is the operation between the two? What's the operation?
Addition.
So, what's 3x plus 4x? 3x plus 4x is 7x. You just brought this down. 5t minus 1 is just like x. Yes, sir. Well, you got to group them where you can have that 5t minus 1 is the key. If you don't get these two to match, you're in the same boat that you started. I didn't like it because the way it was set up right here, you see anything in common right here? That's usually a dead giveaway. If there's nothing in common here, and you got something in common here, these two are never going to match. You have to have those two match in order to simplify the problem down. Because 2x plus 2x is 4x. 5t minus 1 and 5t minus 1 comes down as a 5t plus 1, 5t minus 1. This is just like 3x plus 4x is 7x. Now that's a 2 by 2. Well, what does a 3 by 1 look like? By 1 grouping, looks something like this. How many perfect squares do we have in that problem? Nope. Huh? 3. Name them. That's not rhetorical. I want you to name them. love it when y'all are confident. When y'all are confident, I hear the answer. When y'all are not confident, it's okay, the x squared. What else? Y squared. How many we got? How many do we have in the previous problem? Zilch. Which one has more? This one. So that's a dead giveaway to 3 by 1. What is 3 by 1? Root of what? First 3 and the what? Right, did you? What you got on the left-hand side? Shortcut number what? Shortcut number 2, Hubert. That's right. Or shortcut number 1, Hubert. That's right. I don't see anything in math on that these. Sure, there's light on.
Can I start those lines?
No. I got to. I'm not going to sleep.
She cooking.
I think y'all did it on purpose. All right.
Take those slides.
Metric.
Today's one of those
Right.
days. We gotta get a shot.
After 4 classes, my brain gets to be mush. I'm sorry, dude. Monday weeks is rough. All right, so what does that give you on the first problem, on the first trinomial? X plus what? X plus 2 quantity what? X plus 2 raised to the second power, that's shortcut number 1, minus y squared, and then what is this? Shortcut number 3, Hubert, that's right. A squared minus what? B squared is equal to A plus B times what? A minus B. That's your final answer. Now, in all fairness to your Math 102 teacher or your Algebra 2 teacher, 9 times out of 10, your Algebra 2 teacher or your 102 teacher is going to hammer reverse FOIL and shortcuts before they hammer these. Okay? So, chances are you may not have covered a lot of these, or 2 by 2 or 4 by 1, 3 by 2, 3 by 1. Because usually the algebra teacher is trying to get you to learn how to use reverse FOIL and the 5 shortcuts. So don't feel bad. If your cobwebs are a little bit thicker on this, it's normal. And these are not used a lot. You know, if you're given 100 problems on a test, you're talking about 30%. Because these are not used. Most of your problems that I gave you a factoring test would be shortcuts, the 5 shortcuts, and reverse FOIL. Prende? Alright, that's 2 by, yeah, that's 2 by 2. Alright. I don't want to do that one, but that's got a common problem. I mean, that's got a common fact. I want to do a reverse FOIL just for that. You know, they're doing shortcuts. All right, well, let's do shortcuts. If I wanted to that one's shortcut number what? No, 3. Difference of 2 what? Squares. What is the square root of 16r squared? What is the square root of 121? So your answer two indicators that says this is not a perfect square. Excuse me. What are they? Well, can't take the square root of 8. That's right, class, you can. What else can you not do? Can't take the square root of a cube. That's right, class. Y'all suck. All right. You can't take the square root of 8, and you can't take the square root of what? X cubed. So if you can't take the square root, that knocks out how many of the shortcuts? First 3. So that means you're going to have to revert to number 5. Why didn't I say 4?
Minus sign.
Because it's minus sign. So the only one you could be able to do is shortcuts number 5. I'm sorry, 4. No, 5. So what is the cube root of 8x cubed? 2x. So a is equal to 2x. And b is equal to, I'll do that, square root of 1 is 1. So b is 1. So all you got to do now is plug and chug in the shortcut number 4, which would be what? A cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So that'd be 2x, let's do it, 2x minus 1 times 4x squared plus 2x plus 1. That's it. Factor by any method. I'd factor, I'd do it 2 by 2. Those are all shortcuts. We're not going to spend a lot of time on those because hopefully you already know how to use it. So. R3. Sorry about that. Y'all can keep the settle down, okay? Watch. R3, what is the domain of a function?
It is the X.
What is the X? It's the input values for
The X.
X. It's the input values for X. So if I tell you to only use -2 to +2, what's the domain of the function? -2 to what? +2. Is there a 3 in your domain? No, you can use 5. No, you can only use -2 to what? Now, if you can only use -2 to +2, what will that affect? Your values for what? Y, good, which is the range. So if I plug in, let me give you an example. I'll show you an example. This is very important that you understand domain and range, especially if you hadn't had it in a while. Use dang old regular parameter. And 0, 0, 1, 1, 2, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4. guy right here. And I had just manipulated the what? Not only did I manipulate the domain, but I also manipulated the what? The range by doing away with what? The arrowheads, depending on where you're from. A-R-R, pronounce it however you like. Arrowheads. So now my domain, what is my domain in this universe?
3.
Well, we agreed from left to right. So negative 3 to what?
3.
Domain is negative 3 to positive 3. Then if the domain is affected, what else is affected? The range. So what is our range? It used to go on to infinity, but now it doesn't. What does it go to? 0 to what? 9. That's right, guys. No. Where does the function exist? 0. And where does it end? Where does it end?
Right there.
At y is equal to what? 9. Because what you get when you plug in 3 squared? Here's 3. 3 squared is what? 9. Negative 3 squared is what? 9. So what's the highest product that your domain can produce? 9. And that's the whole point behind domain and range. You got to think of, for some of you space geeks, for some of you technical geeks, I like to consider myself a space, I'm a Trekkie. I like space, I like Star Trek. I like Star Wars, okay, but I like Star Trek. But if you think there's one episode where the Enterprise is vanishing, and that's because the warp bubble is bigger than the ship, but the warp bubble is collapsing. And the warp bubble is collapsing like this, so if you are caught right there at the warp bubble, you vanish because it comes in and you're gone. So your universe is only as big as that bubble. How big is our universe here? From negative 3 to what? What if I want to use 5 as x? Can't. It doesn't exist. And that's what domain is. Domain is the numbers that you can use in the function. And the domain directly affects the what?
Range.
Right. So, how do you find the domain of this function? Well, you got to find where x blows the function up. Because you cannot have a function if the function blows up. You can't do it. Now, a lot of you are saying, where does it blow up? What does that mean? Well, that's the term that we use in Clementine. I don't know if they use it now, but it's basically when a function does something weird, it blows up. And when you get a EROR in your calculator, that means it's blowed up somewhere. In other words, it won't work. Now, you have to worry about the domain with 2 types of functions. You have to worry, and you might want to write this down if you've never understood it. You have to worry about 2 functions. Two types of functions with your domain. And that is a rational function and a radical function. Why do you need to be weary of your domain with a rational function and a radical function? Somebody help me out. Why? Such a disappointment. What's a rational function? Well, f of x. Somebody tell me what rational means. Rational means ratio, oral ratio. What's a ratio?
It's a fraction.
There you go. You're on the ball, man. X plus 1 over x minus 2. What can you not have in a fraction?
Yes.
No, you're wrong. You're such a disappointment. hat on, cover up your face. What can you not have in a rational function? Close. Can you not have in a rational function? Can you not have in a rational
X
function?
minus 2.
No, you said negative. I said you're getting close.
The opposite. 0.
Zero. Where? Where can you not have zero?
Denominator.
Function will blow up.
That's what I was getting at when I was saying X might be the opposite.
Okay, I'm sorry. Why? Well, get your calculator out, because some of y'all go to the bathroom with your calculator. Some of you name it. Some of you have a little pillow and a little bed for it. In other words, y'all think it's the Bible. So punch in the calculator. 5 divided by 0. What will it give you? An E-R-R-O-R. Okay? And that means that the function blows up, because 0 cannot be in the denominator. What is a radical function? You take the square root of 0. What can you not have in a radical function?
Can't have zero.
Now you can have 0, square root of 0 is 0. You can't have a negative. So you cannot have a negative function or it'll blow up. So these are the two that you need to worry about. Which one is this one? Rational. Good. So set the denominator equal to what? 7x plus 13 is equal to 0. So we're going to find out what number will give us a 0 with the denominator. And when you use any number in the world except for that number, because what will that number do? Blow up the function. So subtract 13. Divide by 7. So x cannot equal negative 13 sevenths. So what's the domain of this function? All numbers except for what? That's it. So you put that in there however you want. Same thing with the radical. Except with the radical, you've got to think what numbers will give you a negative. So let's do that one that I just wrote down on the board. Right there. What do you do with that radicand? Set it equal to what? Now, x equals negative 2 will give you what? 0. You can have 0, but what can you not have? A negative. So you use negative 3. You use negative 4, negative 5. What will negative 3, 4, and 5 give you? What? Negative 3 will give us a what? A negative. What will negative 4 give us? So we can use all numbers as long as they are greater than or equal to what? Negative 2. So x is greater than or equal to negative 2. That's the domain of that function. So your domain is what can exist in your universe. Depending on what the instructions say, what the test says, or what the teacher says. Now, a while ago, I told you that the only numbers that existed in your domain is negative 3 to 3. I have affected the domain. I have told you that your world exists of 3 to positive 3. There's no such thing as an 8-pack. Okay? Why? Because you don't have a 4. There's no such thing. In your world, it's only a base of 3. 1, 2, 3 to the right, and 1, 2, 3 to the left. Therefore, your range only exists from 0 to what? 9. Now, when the domain is not affected, or I haven't put any restrictions on the domain, then you go to this and you say, okay, set the denominator equal to 0, and I can use any number I want to, but I cannot use 2. I can't use 2 here. And I can't use negative 2. I can use any number greater than negative 2 in this one. So here we go ahead and put here the domain exists of x is equal to any number except for negative 13 over 7. problem right here. These problems you do in first semester calculus, the first couple of weeks in first semester calculus, and people forget how to do them. People fail first semester calculus because they forget what we're doing in this classroom today. They forget by the time they take trig, and they forget to keep this, keep the 102 notebook, and keep this notebook. And the week before you start calculus, you go over these notebooks because it's going to get you when you take first period of calculus and they ask you to solve this, and you're going to go, "Ooh." And meanwhile, 2 or 3 minutes later, they're already on another chapter of algebra, and you're still trying to figure out how to do this. How do you do it? Well, factor out a common term. Let's factor out a common term. What's in common with the top? What's in common with the bottom? And what do you get? What happens to the y minus 2? And that's what you're going to be doing in the first week of first semester calculus. You just won't have a limit out here. Limit as y goes to infinity. And then you're going to do this, and you're going to say the answer is 3 sevenths. Those are the two things. But see, you see where you could easily forget how to do this. Some of y'all forgot about domain and range probably. Some of y'all forgot about the shortcut. If you don't stay on this stuff, you will forget it. And you'll forget at the worst time, and that's the first period of calculus. Hello? Oh, sorry. Oh, yeah. Here's one. Limit as z approaches infinity, and they'll just throw it to, that'll be a test question, and you're supposed to solve it. So what are you gonna do? Factor. A trinomial in algebra is worthless unless you what? Unless you factor, using the reverse FOIL or a shortcut. What are you doing? That means you need to start by pencil and paper. And since they're the same factors, only different signs, you shouldn't have to take that long. Z, 5 and 7. Thing over. Negative and negative. Over. Z. And that's going to be a positive 7. And a negative what? And what happens? You get z minus 7 over z plus 7. Now right now, some of you are going, Collie, how do you put signs? If you're one of those people, you need to be going over reverse FOIL. Over it right quick. In this problem, let's go with z. Break up the first term, starting with z. Break up the last term, starting with 1. 1 times 35, 2, 3, 4, 5 times 7. 1 is 35, 5, and 7. Add or subtract this one, add or subtract this one. We want a 12. Let's see, 1 and 35 will give us a 36 or a 34. 7 and 5 will give us a 2 or a 12. So it's not 35 and 1, so it's gotta be what, 5 and 7. So you put a 5 and a 7 there. This sign right here means that the largest number has to be negative. So what's larger, 7 or 5? 7. So you put a negative right there. What does this sign right here say? This positive says what? That both your signs have to be what? Like. So that's negative. What is this one? Negative. Now you do the same thing with these two. Now, luckily, they're the same number. You just got to find the sign. So Z, 7 and 5. This tells us that the largest number has to be positive. Which one's the largest number? 7. So this is positive. What does this say? Like or unlike? Unlike. So if this is positive, this is negative. And that's the reverse of the y of both of them. So you should remember those. If not, you can go over that video for 500 or 600 times if you need to. That's why I put it on there. So you can do it about yourself. All right? What do you do on this one? Well, is there such thing as division by fractions?